Hey everyone, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. I am joined today by Robert Herring. He is Senior Project Manager for Pittsburgh Water and Sewer Authority, and we're going to be talking about the large diameter sewer rehabilitation program in Pittsburgh. So, Robert, thank you so much for being here. I appreciate you taking the time.
Oh, thanks so much for having me. I appreciate the opportunity and I hope your viewership finds our conversation helpful.
Yeah, I hope so as well, and I think they will. I had seen this release about this sewer project that you had done, and it was kind of near the Pittsburgh Zoo, and had reached out about that. Could you explain kind of a little bit about the service area impacted by that particular project, and we'll dive into the sewer rehab program after that.
Yeah, certainly, the work we just completed near the Pittsburgh Zoo was part of a project that's kind of was the first one in our revamped large diameter sewer rehab program. This program is designed to, rehab sewers over 36 inches in diameter. We serve an urban environment like most cities on the East Coast. Our sewer system is a combined sewer system largely. And so, the reality is we have a lot of sewers that are over 36-inch diameter. And so the program is intended to address that. The work completed near the zoo was part of what we called our 2020 large diameter sewer rehab project. You got to love engineers and how they name projects. The next one was called the 2021, so on and so forth. But the project itself actually contained three separate and distinct sewer segments.
Oh,
They were all selected due to known structural deficiencies. So we knew there were things going on with these sewers, but also all three of them had really high consequences of failure. When we asked ourselves, what if they were to collapse? I think all of us had spikes of anxiety, which is why, they were selected. We want to be addressing these things before they become catastrophic collapses or anything like that. The, we had two sewer segments near the zoo. One of them was a 4-foot diameter brick circular sewer, and the second one was a 5-foot diameter brick circular sewer. And both of those segments were rehabilitated for about 700 feet. The upstream neighborhoods included Highland Park, Morningside, Stanton Heights, East Liberty, Garfield. So a number of neighborhoods. The third and final sewer segment was actually an 8.5-foot by 8.5-foot oval shaped sewer
mm,
that was located in the Shadyside neighborhood, kind of in between the UPMC Shadyside Hospital and the East Busway, which is managed by Pittsburgh Regional Transit. Those neighborhoods included upstream neighborhoods were Shadyside, Friendship, Garfield, Squirrel Hill, East Liberty. So I know I just named a ton of neighborhoods right there, but the reality is that large diameter sewers have large upstream service areas, which is a good and bad thing. It's bad when sewers collapse and you're addressing an urgent situation because it negatively impacts a large customer base. But in this situation, it's kind of a good thing because you get a lot of value for the money that we invested. We're able to benefit a large group of customers.
yeah, yeah. Well, one of the things that was mentioned in that release was the pipe depth. Could you talk about any challenges that were presented by that depth and how construction teams kind of overcame that and addressed that situation?
Yes, certainly. I think maybe it's best just to talk about how deep things actually were. The 8.5-foot oval shaped brick sewer was 30 feet deep. So that's
Oh,
from the ground surface elevation down to the invert. So that's the bottom of the inside of the sewer main. The 4-foot diameter circular brick sewer is 55 feet deep on average.
wow.
And yeah, the most ridiculous one was the 5-foot circular brick sewer. That one was 80 feet deep. And so normal depths for a sewer are somewhere around 15 feet, 10 to 15 feet, deep enough to serve basements for customers, and allow gravity connections of these private sewer laterals. The
Mhm.
reality is we serve an urban area, and these sewers weren't installed that deep back in the day, but the placement of fill over time has caused them to become that deep. I'm not sure how familiar you are with Pittsburgh topography, but we're very proud of our rolling mountains. And there's not many flat spaces to build parking lots and buildings and things like that. So it is a reality that we face in our service area that fill placement has caused some of our facilities to be so deep. But we're engineers, we're here to solve problems. The depth was kind of just a problem that we had to work around and plan for, which is what we did. Some of the big areas where the depth did play a role was when we were doing technology selection. So our design engineer did a preliminary design report And the depth of the main, frankly, eliminated a lot of options for us in terms of what we could consider.
Hmm.
Um, so we really prioritized technologies where we could actually just access existing manholes rather than have to construct any sort of big access pit or anything like that. Accessibility was an issue. Like I said, we wanted to use existing manholes. At the 101-inch oval brick sewer, we had to find a buried manhole, raise it to grade. It was about 10 feet deep. Thankfully, we were able to find it, raise it, and the contractor was able to use that access. One of the sites had sufficient access as is. We kind of had to walk through a field of weeds and you do that thing with your boot where you start trying to find manhole lids, and we were able to find it. And then the third site had sufficient access. So we were pretty fortunate that we didn't have to construct any brand new accesses as part of this project.
Hmm.
Depth played a role in cost consideration. I'm a public official. We're a public authority. We get our funds from user rates, sewer bills,
Hmm.
water bills. And so we take it very seriously. We want to be using these funds responsibly while also maintaining the asset. So we wanted to make sure that those funds were being allocated responsibly.
Hmm.
Bypass pumping was an issue. Typically, for bypass pumping a small diameter, you use a pump. To have 80 feet of elevation head certainly is possible. There's pumps that do that, but are they temporary pumps? Usually those are fixed installments or fixed pump stations. So we had to do our homework to make sure that each of the three sites was capable of having an internal bypass. An internal bypass is when you kind of put in sandbags and you dam it up and you have a gravity sewer pipe mounted to either the sidewall of the sewer inside or at the invert. And thankfully, we were able to confirm that and design for that condition. And then I think the last point with depth, and it's kind of the elephant in the room, is just safety. You know,
Yeah.
I don't care how fun the Ninja Turtles made it seem to be down in a sewer, but it's a hazardous environment. I think everyone's aware of hydrogen sulfide. That's a gas that could be found in sewer mains where, if you breathe it in, it can impact your body's ability to absorb oxygen, and it can lead to fainting and eventually death. The other concern we had was we have a combined sewer system. And so the flow conditions in those mains are much different when you look at dry weather versus wet weather. For example, the 60-inch sewer, we had a flow monitor installed. The dry weather flows were about 1.7 million gallons per day, whereas the wet weather flows were 16 million gallons a day. So it's a 10 times spike. So, just imagine you're the contractor and you're down there in the sewer, you know, what if? It's once
Yeah.
again, we're playing that what if game. What if a summer thunderstorm comes up out of nowhere? You
Hmm.
know, we had to plan for that. We had a lot of things in the contract documents. Everyone was properly trained. The local fire departments were notified of the work. So we did a lot of planning on the safety side. And above all, we're just so grateful that the work was able to be completed successfully and safely.
Yeah. Could you talk about some of the technology that you used for this? I know that trenchless is becoming a much bigger thing. Was that something that you utilized here, or were you utilizing other technologies instead?
Yeah, we had to use it. It's so deep that, open cut wasn't feasible. I know you and I are just talking here today, Bob, but the reality is I'm standing on the shoulders of the team that helped make this a reality. We
Hmm.
had GPD Group was the design engineer, construction management was done by Hatch, and the inspection was done by SciTech. Our contractor came all the way from New Jersey, Spinello Companies, and then our supplier of the geopolymer material, which I'll talk about here in a second, was GeoTree. And I'm just so grateful we had such a harmonious team kind of attacking this problem and this project. And I think that certainly led into the successes. One of the first steps for the design engineers to do a preliminary design report. And what PwC said is we want a 50-year design life and we want a fully structural repair. And so
Hmm.
they go out and they kind of cast a wide net and look at all of the available technologies that are out there for large diameter sewer rehab. So just to name a few, we looked at slip lining, segmental slip lining. We even considered open cut, even though we didn't think it would be it, but
Hmm.
at least to analyze it, cured in place pipe, spray applied liners, spiral wound plastic pipes, pipe bursting. I'm not trying to name all of them right here, right now, but we certainly cast a wide net and kind of analyzed all of them, came up with a way to grade them based on each specific
Hmm.
sewer. So we wanted to know, the general applicability. I call it the common sense metric.
Hmm.
Is this possible? We considered the ground site preparation, or another way to say it is just construction disturbances.
Hmm.
How messy would it be to implement this technology? We considered bypass requirements. We talked about that briefly before. Construction flexibility, that's a big thing. Are they going to be able to stop and start the work? We knew we get storms. We knew that the flow spiked. And so we knew that was going to be a reality for the contractor.
Hmm.
Hydraulic capacity of the main. We wanted to make sure we weren't creating a bottleneck in our system. So that was a consideration as well. The lifespan of the repair and also just the cost. So we kind of considered everything. We weighted them all a little bit differently and came up with scores. We ended up picking a spray applied geopolymer liner.
Mm.
And just a little bit about geopolymer, it basically forms a pipe within a pipe.
Hmm.
It utilizes the existing sewer main as a mold. So
Hmm.
basically, you shoot on the liner. It's like a wet mix, like a concrete, and you splatter it against the inside of the sewer main, and you hope it sticks, and then it eventually cures and forms its own pipe. So now we have three new geopolymer sewer pipes basically for these three sewer segments.
Hmm.
Geopolymers, when it cures, it looks like concrete, but there are some differences in the chemistry as compared to concrete. It contains a lot of aluminosilicates that form a linked polymer network. A polymer is basically just large molecules that link together in a repetitious way, and it creates a really strong material. Um, and So we were kind of excited to use it. It's also fiber reinforced. I went out there in the field when they were
Oh.
doing work, and I actually picked up a little bit of the wet mix on my finger, and I was looking at it. I don't know if you have a dog, Bob, but the best analogy I can come up with is like dropping a bit of food in a house that has a dog, and you pick it up and it's just covered in dog hair. That's kind of what
Okay.
it looked like. It looked like cement wearing a wool sweater. You can't
Interesting.
really see it when it cures, but you could see it really well when it was in a wet mix.
Hmm.
And then it has enhanced chemical resistance as compared to concrete. So it had a lot of cool attributes. Um, they also claim there's no cold joints. So if you have a cured geopolymer liner and you install new wet mix, those two will speak to each other and link up and form a solid unit.
Wow.
That was also very appealing to us. So during construction, the way it was done is it basically gets delivered to the site, like in those Sackcrete concrete bags that you see at
Hmm.
your home improvement stores. They mix it in a mobile mixer they bring on the site. There's a water meter attached to the side of it. They dose a very specific amount of water, and then it dumps and loads into a hopper that gets fed through the discharge hose all the way down the sewer where the applicator is, and they have a gun and they shoot it onto the walls.
Hmm.
Um, the way our contractor did it is they first sprayed the sidewalls and the crown, so the side and top of the
Hmm.
sewer. Once that's cured, they installed the internal bypass and they did the invert.
Ah. Okay.
And they actually had crews behind the sprayer with trowels and brooms. So it's basically a really fancy sidewalk. That even though they're in a sewer, they're making it, they're doing the finished concrete work. It looked really nice. And
Hmm.
so, during work, we were taking test samples for compression testing, flexural testing to make sure that the material complied with what they said it could do. And it did. And we took random core samples as well. So they went down there with the drill bit and took out some holes to make sure that they were getting the required depth per the design.
Yeah. Well, that's fantastic. It sounds like an excellent use of technology to make a pretty heavy impact with not too heavy of an investment. You're able to make a lot out of the money that you used.
I agree, and we're so grateful for that.
Yeah. Well, thanks so much, Robert. I appreciate you taking the time and talking about this and telling us a little bit about the program that you guys have in Pittsburgh. And to everyone who's watching, check out our video description below. We'll have a link to the press release that I have referenced earlier in the episode. And once more to Robert, thank you so much for being here.
Thanks, Bob. Nice meeting you.